Welcome to Train Signal. You're watching a video about securing network traffic with IPsec. In this video, I'll start off by explaining exactly what IPsec is. We'll take a look at the different IPsec protocols. I'll explain the difference between tunnel and transport mode. We'll take a look at the different authentication methods that are used by IPsec. And then we'll go into the Windows Server 2008 operating system and I'll show you how to configure IPsec policies, and then also how to set up a connection security rule. So first of all, what is IPsec? Well, IPsec is quite simply something that is used to secure data sent between two computers. Now, these two computers may be within the same local network, or it could be between two different networks. But the bottom line is when some node, we could call it, some device wants to send data to some other device and you need that data secured, that's where we can use IPsec. Now, IPsec not only keeps the data confidential through encryption, but it also ensures the authenticity of the data through something called mutual authentication. Now, by mutual authentication, what that means is if, for instance, a client is attempting to connect to a server, typically you would see the server asking the client to authenticate itself to get in, right? If you're out there trying to get to some data that's out on the network, typically you want to get into that data. The security guard standing outside that data would say to you, "Let me see your ID. Who are you?" Well, in the case of IPsec, not only does the client have to authenticate itself to the server, but the server would also have to authenticate itself to the client so that both parties have a strong guarantee as to who the other party is that they're dealing with. Now, I mentioned client and server, but it doesn't have to be client server per se. It just would be two computers that are communicating. Now, one other thing to know about IPsec is that it is a standard. It's not a Microsoft-only technology. So therefore, it can actually be used between different platforms, whether everything is Windows on your network or maybe you have some non-Windows platforms on your network as well. Now, IPsec primarily uses two protocols. There are more protocols involved with IPsec, but the two I really want you to become familiar with are the encapsulating security payload, or what's much easier to say is ESP, and authentication header, or simply AH. And to really simplify this, I'll tell you what, if you were to go out, let's say on the internet, and you look up these protocols, you can see some pretty lengthy explanations and definitions. But to keep it real simple here, I just want you to hang on to one short piece of knowledge, and that is that ESP is used for the encryption of the payload, for the actual encryption of the data, whereas AH is used for the authentication of the sending. And you'll notice in parentheses here I have "and receiving computer." And the reason I put "and receiving" is because remember, there is a mutual authentication. So again, just real quick, real easy, one simple thing to remember. ESP is used to encrypt the actual data, the actual payload, and AH is used for the authentication, and so you can verify the validity of who's actually transmitting and receiving the data. Now, there's two different modes that are supported by IPsec: tunnel mode and transport mode. Now, tunnel mode is something that you would use very rarely. There are some rare circumstances where you will set up an IPsec tunnel to secure data traveling between two gateways or two routers. And typically this would be if the two gateways were connected via an unsecure network, like the internet maybe. So maybe you have two different offices and those two offices are connected via the internet. That's really the only common connection they have. And so you can use an IPsec tunnel to connect those two offices by taking the endpoint router or gateway to that office to the gateway in the other office. Now, The reason I say that this is very seldom used is because we would more typically use a secure VPN tunnel at that point. It is more common that we would use something like L2TP, which L2TP does actually utilize IPsec as it turns out, but to have a true formally set up IPsec tunnel, not very common. What is typically used and is the default behavior of IPsec is transport mode. This would be used when you're looking to secure data just between computers within a network. So if within your network, even though you may be behind firewalls, you may be in what feels like a secure environment, on the chance that either A, somebody has hacked into your network, or B, maybe even somebody who is already on the inside, there's maybe certain confidential data you want to make sure that no one else sees. You can then use transport mode to secure data from one computer to another within that network. Now I will tell you that we will see where we set up these modes when we go into the operating system to set up a policy. IPsec supports 3 authentication methods. The first is Kerberos. Kerberos is what is in a Windows environment most commonly used. The reason is because it is quite easy to set up. If you are working within an Active Directory environment, which also uses Kerberos for authentication, there's really nothing specific you have to do. You just say, hey, I want you guys to authenticate using Kerberos, and then Active Directory pretty much does the rest. The next option would be certificates. Now this would be used typically when Active Directory is not available. That is really when you would want to use certificate authentication. It is possible to use when you are in an Active Directory environment and maybe you want to increase security even beyond the high level security of Kerberos used within Active Directory. But you need to understand that when you're going to authenticate using certificates, there's going to be a lot of extra work and overhead that's going to go with it because you're going to have a certification authority who is going to have to manage certificates, and certificates are going to have to be distributed to the computers for the purposes of authenticating. So it does provide for a higher level of security, but it also comes with a lot more work. And the last choice would be something called a pre-shared key. And it is pretty much just that. It means that on one computer you enter in a physical key, like you literally type it in. You could type in any old password, and then any other computers that computer wants to communicate with, well, those computers also have to be set up with IPsec and have to have that password, if you want to call it, keyed in to their IPsec configuration as well. And this is the lowest form of security and should only be used in test environments. If you're just trying to test whether IPsec is working between a couple of computers, that's really the only place that you ever should be using a pre-shared key. I've used it many times in the classroom for demonstration purposes, but I can tell you that I've never, and I mean never, have used it in a production environment. Alright, well, that right there is the absolute basics to IPsec and what it's made of. So now let's actually go into one of our servers and take a look at how to configure IPsec. Okay, now for this demonstration, I will tell you, we're going to do everything pretty much from New York DC1, and the reason why is because IPsec policies would typically be managed with group policy. So we're going to go on to the domain controller to look at IPsec policies through group policy. But before we do, I want to take you into New York Member 1 real quick, just to show you that it can be done on an individual computer. So let's go into New York Member 1 now. And once we're in the New York Member 1 server, I'm going to click on Start, Administrative Tools, and where you go to manage IPsec would be the Local Security Policy. In the Local Security Policy window, you'll see right down here that here's where you have your IPsec, and IPsec is technically Internet Protocol or IP security, but IPsec policies on the local computer. And you will also notice that if I click on it, there aren't any. But I could right click and say create a policy. Now I'm not going to do that right now because like I said, this would typically be done through group policy. So let's go ahead and close out of New York Member 1 and let's go into our domain controller, New York DC1, and go into our group policy editor by clicking Start, Administrative Tools, Group Policy Management. And as we've done with some of the previous videos, we're just going to go in and edit the default domain policy. Typically, you would create separate group policies that would work within the scope of certain computers that you are trying to manage. But in this case, we're just trying to see how the interface looks. So what you would do is under Computer Configuration, you expand Policies, expand Windows Settings, expand Security Settings, and here again you find IP Security Policies, and this time it's for the, well, I moved my cursor, you can't see it, the globalmantics.com domain. Now when I click on it this time, you will see that there are 3 policies already there. Now let me go ahead and expand these so that you can see it. The 3 that you have to choose from are Client, which is respond only, Secure Server, where we require security, and Server, where we request security. You'll notice that in all 3 cases, the policy is not assigned. The answer is no. Now, what do these 3 policies mean? These are not only the 3 default policies, but in many environments, very possibly the only 3 policies that you'll need. Client respond only means just that. You would typically assign this to your clients. The clients are not going to initiate IPsec communication because they typically don't have secure data to worry about. But in the event that that client is attempting to communicate with a server that has secure information and a server that is set up to want to communicate securely via IPsec, the client will be equipped to do so. It'll be equipped to respond to the request or requirement of the server to communicate via IPsec. Now I'm going to jump down to the bottom one next, which says Server Request Security. This is an interesting one for many people. In this case, what will happen is any computer that has been assigned this policy, when it communicates with any other machine, it will make a request. It'll say, hey, I would like to communicate securely via IPsec. And if the other party is capable of communicating via IPsec, then they have secure communications. If the other party is not capable of communicating via IPsec, well then the server says, that's okay, we'll communicate unsecurely anyway. Now this one bothers a lot of people because they're thinking, why would you, if you have a reason, why would you ask and then say, it's not that big a deal? Well, the most common scenario where that would happen would be if you had an environment where, let's say, almost all of your clients were Windows 2000 Professional or newer operating system, and they could support IPsec. But you had, let's say 2 or 3 people in the company who maybe they have their own laptop and for some reason they're still running, we'll say like Windows 98, and they're incapable of doing IPsec. Well, in that instance, you may want to go ahead and say, all right, well, in an effort to increase security, we'll go ahead and implement the Server Request Security IPsec policy, while at the same time, when those 2 or 3 users who cannot work with IPsec want to communicate, we're going to go ahead and let them communicate anyway. I know it's a little far-fetched, a little out there, but hey, you never know. Now the last one is the middle one here, Secure Server. Secure Server requires security is just that. You assign this to your servers that have highly confidential data of a real secure nature that basically says, look, you want to communicate with me? It's going to be done via IPsec or not at all. Now if you think about it, that satisfies most situations, most scenarios. So for all practical purposes, we typically would only have to pick one of these particular policies and then assign it. And the way you assign it is by just right-clicking on it. I'll take the client here. Right-click and select Assign. Okay, now that I've assigned it, it says Policy Assigned. Yes. Now you can only have one assigned at a time. So for instance, if I go down to Server Request Security and then right-click on it and select Assign, you see here that this policy now turns to yes, and the client policy now went to no. You can only have one at a time. Now I'm going to go ahead and right-click on this one and unassign. That's how you can stop IPsec. And you'll see that the policy assigned goes back to no. Now if you want to create a policy of your own, then what you do is you come down here to where it says IPsec Policies, right-click, and select to create an IPsec policy. And you get the IPsec Policy Wizard. Click next to the welcome screen. Give the policy a name. So we'll call this Secure DNS Lookup. Okay, because what we're going to do is go ahead and say that if anybody wants to communicate with this server doing DNS lookup, they're going to have to do it through this policy. Go ahead and click on Next. Now, here's where we have a choice as to whether we want to activate what's called the default response rule. And you'll notice it says for earlier versions of Windows only. What this basically comes down to is, do you want to create a rule within this policy that is just a default response to any other IPsec requests? In other words, if for some reason you're attempting to communicate with another computer that has IPsec configured maybe slightly different than this computer, do you want to go ahead and by default respond to that request and communicate securely? Or do you want to make it that it is only done explicitly the way you set up a rule on this policy? Typically, I would think that you would say, yeah, go ahead and activate the default response rule, which means if somebody else is set up for IPsec, we'll go ahead and match so that at a minimum we have secure communications. The only scenario where I would say not to do this would be if you were really going to set up something that was of a secure enough nature that you were going to require some very detailed specifications and you were not willing to veer from that at all. Alright, so let's go ahead and click on Next. Here's where we get to choose the authentication method. And as you can see, we have Active Directory, which is the default. It'll use the Kerberos v5 protocol. We could choose to use certificates, but then you have to go ahead and get a certificate from a certification authority, which we don't have set up right now, so I can't use that one. Or here is the pre-shared key, and like I said, pre-shared key is where you literally would type in the password. And this is not very secure at all, so we're going to definitely not do that, and we're just going to go back and set it up for Kerberos, which would be how you would typically do it if you were in an Active Directory environment like we are here. Okay, let's go ahead and click on Next. And that completes the IPsec Policy Wizard. So that creates the policy, but right now this policy only has the default response rule. That's all we've done. Even though I named it Secure DNS Lookup, that's just a name. We haven't secured anything. So what we want to do is go in and edit the properties, which is checked by default. So I'm going to go ahead and click Finish, and you'll see here that it takes me right into, well, let me move this window so that you can see it created a policy, but it took me right into the properties screen for this policy. And you'll see that you have the default response rule already in place and the box is checked. This is another reason why I would go ahead and say yes pretty much to always working with the default response rule, is if we don't want this rule to affect this policy anymore, just clear the checkbox. So that's really the reason why I would always add it there, so it's at least an option. Now if I go ahead and check the box again, you basically say that this is not valid for Vista, it's only valid for earlier Windows, and we'll say yeah, that's fine. Alright, what we need to do now to complete this policy is we need to add a rule. So let's go ahead and click on Add, and you get the IP Security Rule Wizard. Go ahead and click on Next, and here's where we're going to get to things like, do we want to be in transport mode or tunnel mode? By default, we're working in transport mode. This rule does not specify a tunnel. If we wanted to work in tunnel mode, well then we would have to go ahead and put in the IP address of the other computer, the computer on the other side that we're going to go ahead and create a tunnel with. So this rule does not specify a tunnel. We're going to go back to transport mode. Click on Next. Now we get to determine whether this rule is going to apply only within our local area network, or if this rule will only apply to remote access clients coming into our network, or possibly both. Again, I would say it is typical to leave it alone with both, all network connections. Go ahead and click on Next. Now, here we have the IP filter list, which is where you get to pick what type of IP traffic you're going to affect with this rule and with this policy. Now, there are two there by default: all ICMP traffic and all IP traffic. So all IP traffic would be just that. It would be basically, look, I'm creating a rule and I want this rule to affect all communications. All ICMP traffic, the reason they have that there is because this typically would be used when this was going to be a rule where you were going to maybe permit some unsecured traffic, as opposed to a rule that is going to restrict traffic. You may have other rules that restrict traffic, and here you would allow ICMP, and the reason why is because ICMP is used for troubleshooting purposes. So you may want to go ahead and allow all ICMP traffic for troubleshooting. But in this case, we said we wanted to go ahead and secure DNS lookup traffic. So I'm going to click on Add to add a different IP filter. And here, I'll call this DNS lookup. And then we're going to add the specific filter itself. And now this box right here is the most important thing I want you to look at, is where it says mirrored. Match packets with the exact opposite source and destination address. Before Windows Server 2008, when we were going through this, you used to have to set up both the source and the destination, and essentially probably 90+% of the time, you're really only worried about a specific type of traffic, and so you would set it up with this mirrored configuration on the opposite side, and it was really just extra work. So now by checking that box, you'll see here when I click on Next, whatever I set up for the source, so I could say coming from anybody, destination, we could say going to anybody, or we could say a specific IP address or subnet, or look at this, we could say DNS servers. That's pretty cool, huh? So we're going to say pretty much coming from anybody going to a DNS server. And the protocol is going to go ahead and be TCP port 53. And finish. And now we have set up right here an IP filter where we're going to go ahead and say pretty much anybody who is connecting with a DNS server on port 53 doing a DNS lookup is going to have to go ahead and abide by this rule. Let me click OK. And now I have my DNS lookup filter, and I'm going to go ahead and click the button to say that that's the filter I want to use. I'll go ahead and click on Next. Now here's where the filter action comes into play, and I'll tell you what, this is what I was just talking about with when we were talking about the ICMP traffic. This filter was set up, and the action could be to require security, to say, hey, if they meet this filter, we're going to require IPsec communications. Or we could set it up to request IPsec communications, which works similarly to the server policy where we request security, but if they can't meet it, then we go ahead and don't use security. Or we can say, no, we want to permit unsecured, non-IPsec traffic meeting this filter. Okay, so maybe if in this scenario we wanted to go ahead and allow DNS lookup, even though other transmissions are secure, we would select permit. But because we said we wanted to secure DNS lookup, we're going to go ahead and require security. Now, we could add additional filter actions, and I'm going to click on the button, but I have to tell you, this is something that is much more advanced, and I wouldn't worry about right now unless you are going to pursue a very specific career as a security professional. Because when I go in here, you'll see, I'm just going to leave this alone because we're not actually going to do this. You will see here that although you have permit or block, which is real simple, and quite frankly, there's no purpose in doing this, the negotiate security option now gives you all kinds of options. Now here we can say allow unsecured if a certain connection can be established, and we can go in here and we can do whether we want integrity and encryption or just integrity, or we can get into real custom, and we can get down here and we can break it right down into what type of integrity, what type of encryption, etc., etc., etc. I'm going to go ahead and cancel out of this right now because I just wanted to show you we can get real detailed with this, but typically, unless you have real isolated scenarios and you are working as a very detailed security engineer, you're not going to mess with any of this. You're going to pick one of these three. So we're going to say require security, click next, and now again we have to pick an authentication method for this rule, and so we're going to go ahead and again leave it as Active Directory, next, and finish. We now have the DNS lookup rule, and we can go ahead and click OK. Now we have our secure DNS lookup policy. In order to implement this policy, I would need to right click and select assign. Now I'm not going to do this because there's a lot more we would need to do to set this up appropriately on our network. And before you think to yourself, whoa, wait a minute, if there's so much more to do, I need to know what that is. I've told you what it is. When I say there's a lot more to do, I mean in the sense that we would need to actually set up a scenario within our Active Directory infrastructure to where all of our DNS servers were in a specific container, a specific organizational unit, and we would need to assign this group policy to that organizational unit, and then the rest of our clients, the rest of the computers on the network, would then have to go ahead and have that client respond only in order to allow this communication to truly take place. But other than going to the appropriate group policies to set this up, that's really all there is to it. Now I will tell you that another thing that is a new choice that we have here, I'm going to right click, we have Manage IP Filter List and Filter Actions. And you'll see here that here's our filter lists. If we wanted to go ahead and create additional filters, we could do it here without having to actually be within a specific rule. If we want to manage those filter actions, which like I said before, you're really never going to do, or in very rare scenarios would you could do it here again without being in a specific rule. So that is something else that you can do within your IPsec policy management in group policy. So now that we have seen exactly how to set up a policy and rules within that policy, let's see if we can't actually make this work right here, right now. Now the way I'm going to do this is by setting up another policy on two individual computers. Group policy here, I don't want to mess with the entire domain. I just want to try this between two individual computers. So the first thing I'm going to do is open up another computer and see if we can communicate with New York DC1. So let me minimize this, and let's connect to New York Member 1. On New York Member 1, I'm going to click Start and go to the command prompt, because all I want to do is ping New York DC1 just to prove that right now we can communicate, no problem. Okay, we're getting successful replies and everything. All is well with communication. So let me go ahead and minimize New York Member 1 and go back to New York DC1, and what I want to do now is create an IPsec policy for this specific computer. Now because it's for this computer, not the entire domain, I do not want to use group policy. What I'm going to do is I'm going to click on Start, Administrative Tools, and we're going to go to the local security policy. in the local security policy, we're going to click on IP security policies on local computer. And you will see that unlike in group policy, again, remember, this is blank. You got nothing to start with. You got to create everything from scratch. So we right click on this link right here and select Create IP Security Policy. Click Next. We're going to call this Secure Ping, because what I want to do is secure that ping communication from New York Member 1 to New York DC1. So I'll click Next. We do not want to activate the default response rule because we're not working with earlier versions of Windows, and because we don't want a default response. We want to create specific policies. So I'll click Next, and you'll see that that's pretty much it. We've created the policy, but now we have to go in and edit the properties because, let me click Finish, because we need to create a rule. Now here's that default response rule if I wanted to enable it, but I don't right now. So I'm going to click Add to add a new rule, which of course takes me into the Security Rule Wizard. Click Next. We do not need a tunnel. We'll just do this in transport mode. Click Next. We'll leave it at all network connections. We're not going to be specific right now. Now, again, you may notice that in group policy, we had some filters to pick from. We had two to be specific. We had all IP traffic and all ICMP traffic. Well, when working with an individual machine, you don't get anything to choose from. You have to create it by hand. So I'm going to click on Add, and we're going to call this all ICMP traffic. Okay, so all ICMP traffic. Click on Add. Now we get another wizard. We have quite a few wizards we have to go through here, but fortunately they are wizards, so they'll guide you through everything. So I'm going to click on Next. Mirrored is fine because we want everything the same going both directions. Next. Any IP address to any IP address. ICMP for the protocol type. And Finish. And you'll see here that we now have a filter called all ICMP traffic, which will be from anywhere to anywhere for all ICMP protocol traffic. So I'll click OK, and then we have to actually click the button to select that filter. So we're going to filter to all ICMP traffic, which by the way is exactly what ping uses, so that's why we're picking all ICMP traffic. So I'll click Next. Now on this screen, the filter action, again, in group policy, you would have some choices there. There were 3 choices that were there before, but now we have to do everything manual. So I'll click Add to create a new action. Click Next through this wizard, and we're going to call this Require Security. Click Next. We're going to negotiate security. Do not allow unsecured communication because we want to require it. Click Next. We want both integrity and encryption, so we're using both AH and ESP. Click Next, and Finish. Now, going to require security. Okay, got to select that button, and click Next. We need to pick an authentication method. Although, typically, we would use the Active Directory default of Kerberos. In this instance, since we're just in a test environment, I'm going to use the pre-shared key. And I could type in anything, so I'm going to keep it simple and put in ABC123. Nice, easy key, but the other side's going to have to match if we're going to communicate. So I'll go ahead and click Next and complete the rule wizard, and you will see here that all ICMP traffic, we are requiring security using a pre-shared key. The box has been checked. Click OK, and there's only one last thing we have to do, and that is assign the policy. So I'm going to right-click and select Assign. Now that that policy has been assigned, let me go ahead and close this. Oh, and actually, you know, we need to minimize New York DC1 because we're going to go back to New York Member 1. And I'm going to attempt to ping New York DC1 just like we did before, and watch what happens. We're not getting replies. Oh, there we go. Request is timing out. Communication has stopped between the two computers. Why has it stopped between the two computers? Well, because New York DC1 is requiring IPsec secure communications, And New York member 1 has not been configured with an IPsec policy to comply. So what I'm going to do here is I'm going to do another ping, but this time I'm going to put -T at the end. And the reason why I'm going to hit enter is because the -T says instead of just attempting 4 times and then quitting, it's going to just continually try again and again and again and again to ping. And I want to let this run in the background so that you can see, once we create the policy, exactly when communication starts taking place again. So we'll let this run in the background, and here on New York member 1, I'm going to do the exact same thing that I did on New York DC 1. I'm going to click Start, Administrative Tools, Local Security Policy. In the local security policy, we'll click on IP security policies on local computer. We see that it's blank. Right click, create a policy. I'm going to go through this quickly now because we're just going to do the exact same thing. I'll click next. We'll say secure ICMP, or actually, I'm sorry, we did secure ping. Next. We're not going to do the default response rule. Next. Finish. Add a rule. Next. Transport mode's fine. All connections. We need to add a filter. This is where we did all ICMP. Add. Next. Next. Anywhere to anywhere. ICMP. Next. Finish. And click OK. Select that filter. Next. For filter actions, we need to add an action. And this is going to be require security. Next, negotiate. Do not allow unsecured communication. Next, we'll do both integrity and encryption. Next, finish. We need to select the requirement of security. Next, we'll do a pre-shared key of ABC123, just like we had on the other side. Next, and finish. Click OK. And now before I do anything else, I want to show you, let me come back here to our command prompt. You will see here that the requests are still timing out. Okay, and that's not going to stop. The reason why is because I have not assigned this policy yet. So what I'm going to do is I'm going to right click and assign this policy, and then we're going to come right back here to the command prompt. And what should happen, if this all works, is we should start seeing communications. So let me go ahead and right click, assign, come back here, and you'll see that almost instantaneously we start getting replies. We are communicating once again. Now, this allowed you to see how IPsec can block communication when it's set up on one side and not set up on the other side. But what you can't see, because it's going on behind the scenes, is you can't see that this communication is now encrypted. Meaning, if somebody was on our network right now and had a sniffer running where it was trying to grab packets off the network to see what they could find within those packets, they would not be able to see any data because it's all encrypted now via IPsec communications. Now, with that being said, let me go ahead and close our command prompt window. We need to go ahead and unassign these IPsec policies. And the reason why is because if we leave these policies in place, we may be interfering with other communication with other machines on this network. So you typically would not do this on a live production network, kind of like we've emulated here. You would do this on test machines, or you would do it during test hours, but we need to undo what we've done. So first thing I recommend is don't just delete the policy. I have seen way too many scenarios where you delete the policy but left it assigned, and the registry settings that go on behind the scenes say, oh, okay, well, we're still assigned and we still require IPsec, and I'm not sure how to tell you how to get out of that. Now, actually, there is a way to get out of it. It's by disabling the service, but it's not the kind of thing you want to do. So you want to be very careful to unassign, and then once it's been unassigned, go ahead and delete the policy. Or, quite honestly, you could leave the policy there. You don't have to delete it. But I'm going to go ahead and delete it just to clear things out. So let me go ahead and close this. And we will close out of New York member 1. Let's go back to New York DC1. And here, oh, you know what? I closed my local security policy. So let me go ahead and go back to my local security policy. Go back to IP security policies on the local computer. Let's unassign so that it's not assigning this policy anymore. Let's delete the policy. And in theory, now we've completely eliminated that restriction. And the way that I would actually test this would be to go ahead and go to a command prompt. In this case, because I'm on New York DC1, I'm going to go ahead and attempt to ping New York member 1. And it seems as though all communication is working just fine. So hopefully we've undone everything successfully. The one thing that I would be careful of is if you ever are doing this on a production machine, before implementing IPsec policies, I'd really strongly recommend making a backup. Create an image of the machine, or at least make a backup of the operating system state, or whatever it is you need to do, so that if for some strange reason IPsec gets stuck, you have a way to get back to where you were once before. Now, hopefully, this is a thing of the past. I mean, this is the kind of stuff that we saw back with Windows 2000 where it would get stuck. I haven't actually run into that with Windows Server 2008 yet, but I would be cautious of it. Now, the last thing I want to show you here is how to set up a connection security rule using Windows Firewall. Now, we talked about Windows Firewall in the last video, and there was one significant piece, I guess, that I didn't show you because it relates to IPsec policies. So what I want to do is go ahead and, instead of going into IPsec, let's go up here to Windows Firewall with Advanced Security. And again, remember, you could do this either through group policy or you could do it on an individual computer, typically through group policy. I'm going to go ahead and expand. Let me expand this window, make it a little easier to see. Here you'll see under Windows Firewall, you not only have your inbound and outbound rules, which we talked about in the last video, but you have your connection security rules. If I right click and select New Rule, I can now set up a rule which will associate itself to IPsec, but the main difference here is if you want to control these rules based upon a profile, based upon a computer being within the domain, private or public profile. So this is not something that I see being used in very many scenarios, but in case you have that scenario, you can set up one of these rules. Now, the first thing we have here is what type of rule. The isolation rule is probably the one that would be used most often. It is just a standard rule, and you'll see here, based upon something like authentication or domain membership, or possibly health status, which is something that we'll talk about in the next video when we talk about network access protection. Now, you can also do what's called an authentication exemption, and this pretty much is where you can create an exemption. Pick a computer or a list of computers that are not required to go through a specific form of authentication. Maybe there are certain computers that are contacted regularly. They provide common networking functions but don't have anything of a secure nature. You can make them an exemption. You can set up specific server-to-server communications where you want to specify certain computers, a specific tunnel, which is kind of like tunneling mode in IPsec, where we go directly point to point from one specific gateway to another, or we can customize if we want to use a variety of the options. Now we're going to go just into the standard isolation rule here and click on next. Now, what are the requirements we're going to set up with this specific rule? We can request authentication for inbound and outbound. We can require for inbound and request for outbound, or require for both inbound and outbound. And it really just comes down to what is it that you want to require here. Do you want to have it as a request or a requirement of one or both? We'll go ahead and just leave the defaults because we're pretty much just going through this wizard so that you can see all the screens. Go ahead and click on next. Now again you get to choose an authentication method, and here we have the choice of computer and user authentication, and this is just using Kerberos. Okay, so Active Directory would make it that, in Active Directory we have both computer accounts and user accounts, so we're saying we want them both to be authenticated, or we could choose to simply authenticate the computer using Kerberos v5, again, Active Directory, or we could do the computer only but via a certificate, just like with IPsec, setting up for computer certificates, or we could get into very advanced, convoluted settings that we just don't want to mess with. Now again, we could just go with default, which is where we use the authentication method specified in the profile properties, and then we don't have to worry about it here. Or I would say, if anything, we probably would be using computer and user via Kerberos v5. So let's go ahead and click on next. And here is where we get to go ahead and select the profile. And this, in my opinion, is the most significant component of what we are doing here, which is where we go ahead and set up the way we want, whether we want to go ahead and authenticate. And again, this is IPsec authentication. That's what we're setting up here. Whether we want to do it for the domain and or private and or public profiles for our computers. In my opinion, this is, for the most part, an unnecessary step in almost every scenario. If you're going to go ahead and set up IPsec communication, you can manage it through group policy and you don't need this step. But if you have a scenario where you do, I just wanted you to see this wizard. And by the way, the last piece of the wizard is just giving this particular connection security rule a name and then finish. So I'm going to go ahead and cancel out of the rule because, like I said, I don't see the need for the rule here. We've already set up IPsec policies. We're pretty much good to go. All right, well, that's pretty much it for how you set up IPsec in Windows Server 2008. All right, well, after watching this video, you should now know how to, first of all, explain what IPsec is and know the purpose of the authentication header and encapsulating security payload protocols. And I'll tell you what, those can be a real mouthful. They are very typically just simply known as AH and ESP protocols. And along with that, you should know how to configure and enable IPsec policies, which would require you to understand different authentication methods and transport versus tunnel mode. We also saw IP filter actions, and this is probably the most significant part of what you might do. Although, one thing to keep in mind with our IPsec policies is there are 3 there by default: the client, the server, and the secure server policies, and you most often would just use those existing 3. And along those same lines, you should now know how to set up a security connection rule. It's done through a simple wizard through the Windows Firewall utility. And quite frankly, I only showed it to you in case you get a question on the exam. I really haven't seen a whole lot of purpose for this in production environments. All right, well, that's pretty much it for IPsec. See you in the next video.